Mathematics 9. Week 1 and 2.
Good day, everyone. I am Teacher Jenny, and I will be your math teacher for the school year. Welcome to the first day of our Mathematics 9 class. Our first topic is all about quadratic equations and functions, the solution of quadratic equations by extracting square roots, solving quadratic equations by factoring, solving quadratic equations by completing the square, and solving quadratic equations by quadratic formula.
Topics: Unit A, quadratic equations and functions. 1.0 Introduction. 1.1 Solving quadratic equations by extracting square roots and factoring. 1.2 Solving quadratic equations by completing the square. 1.3 Solving quadratic equations by using the quadratic formula. Key terms: quadratic equations, extracting square roots, completing the square, perfect square trinomial, quadratic formula, factoring, square root principle. General objectives. What you will learn: in this chapter you will illustrate quadratic equations, solve quadratic equations by extracting square roots, factoring, completing the square and quadratic formula. Skills you will use: in this chapter you will follow the steps to solve quadratic equations by extracting square roots, factoring, completing the square and quadratic formula. Why is this important? Quadratic equations are actually used in everyday life as when calculating areas, determining a product's profit, or formulating the speed of an object. Also, many physical and mathematical problems are in the form of quadratic equations. Definition of quadratic equation. A quadratic equation in one variable is an equation of degree 2. Its standard form is x squared plus bx plus c equals 0, where a, b, and c are real numbers, a not equal to 0 and x is a variable. Quadratic equations may be written in various forms. 3x squared, 23x equals 8, 4x squared equals negative 12x, 4x equals square root of 15x squared plus 5x plus 14, 2x squared equals 9, 3x plus 5 equals 2 over x.
All of us remember what quadratic polynomials are. The general form of a quadratic polynomial is ax squared plus bx plus c, where the constant a is not equal to 0. The degree of the quadratic polynomial is 2. So what's a quadratic equation? An equation, as we know, always has two sides, one on each side of the equal to sign. When we equate this general form of a quadratic polynomial to 0, we get the general or standard form of a quadratic equation. Remember that a is not equal to 0 and the constants a, b and c are real numbers. For instance, 2x squared plus 4x plus 2 equals 0 is a quadratic equation. Comparing it to the standard form, we get a as 2, b as 4 and c as 2. A is the coefficient of x squared, b is the coefficient of x, and c is the constant. This is called a quadratic equation in variable x. X squared plus 5x plus 6 equals 0 is also a quadratic equation. Negative 3x squared plus 12 equals 0 too. Yes, you might not see the x with power 1 in this equation, but it still is a quadratic equation. That's because the degree of the polynomial on the left is still 2. Can you find the values of a, b and c in each of these cases? Here are the values. Notice that in the second case, the value of coefficient of x is 0. And that's not a problem at all. The important condition is that a must not be equal to 0. We can say that a quadratic equation is of the form p of x equals 0, where p of x is a polynomial of degree 2. Does it have any application in real life? Say you're asked to build a rectangular football field with an area equal to 7,000 square meters. And you're also told that the length of the field should be 30 meters more than its width. How would you build the field? Say this is the rectangular field. Its area is 7,000 square meters. If its width is x meters, and based on the condition given, its length will be x plus 30 meters. The area of a rectangle is nothing but the product of its length and breadth. Hence, x times x plus 30 will equal 7000. Rewriting this will give us the quadratic equation as x squared plus 30x minus 7000 equals 0. And this is nothing but a quadratic equation. But how will this give us the value of x? That's what we will learn in the coming videos.
Solutions of quadratic equation. 1. Solving quadratic equation by extracting square roots. Rule: the square root principle. If x squared equals a and a is greater than or equal to 0, then x equals square root of a or x equals negative square root of a. To solve equations of the form x squared plus b equals c, where a and b are real numbers, we first use the addition property of equality to isolate x squared and then use the square root principle. Examples: x squared equals 49. X equals positive negative square root of 49, use the square root principle. X equals positive negative 7, simplify the radical. The two solutions are positive 7 and negative 7. Solving quadratic equation by extracting square roots. 2. 4x squared minus 9 equals 71. 4x squared equals 80, add 9 to both sides. X squared equals 20, divide both sides by 4. X equals positive negative square root of 20, use the square root principle. X equals positive negative square root of 4.5, factor the radicand. X equals positive negative 2 square root of 5, simplify the radical. The roots are positive 2 square root of 5 and negative 2 square root of 5. 3. 5x minus 3 square 2 equals negative 32. 5x minus 3 equals square root of negative 32. 5x equals square root of negative 32 plus 3. X equals square root negative 32 plus 3 over 5. Because the square root of a negative number is not a real number, there is no real number solution to the equation.
When a quadratic equation consists of just a squared term and a constant, you solve the equation by using the square root rule. If the square of a variable is equal to the number k, then the variable is equal to the principal square root of k, or its opposite. You use this rule to solve some special quadratic equations, the ones where b equals 0. They start out looking like ax squared plus c equals 0, but the c is usually negative, and its inverse gets added to each side of the equation, so the equation looks like ax squared equals c. Here are a few examples. Let's solve for x in x squared equals 49. Using the square root rule, x equals plus or minus the square root of 49, which equals plus or minus 7. This checks out because 7 squared equals 49, and minus 7 squared also equals 49. Here's another one. Solve for m in 3m squared plus 4 equals 52. This one isn't quite ready for the square root rule. First you have to add minus 4 to each side. So 3m squared equals 48. Now divide each side by 3, and m squared equals 16. So m equals plus or minus the square root of 16, which is plus or minus 4. Solve for p in this one. First, add minus 11 to each side to get p squared equals minus 4. But wait, what number times itself is equal to minus 4? The answer is none that you can imagine. Actually, mathematicians have created imaginary numbers so that these problems can be finished. But right now, we're only concerned with less heady numbers. So, this problem doesn't have an answer, if you're looking for a real number. Alright, no tricks on this one, but the answer may surprise you. Let's solve for q. We actually end up with two completely different answers, not one number and its opposite. We use the square root rule first to get q plus 3 equals plus or minus the square root of 25, which is plus or minus 5. Now we have two different linear equations to solve. Q plus 3 equals plus 5, and q plus 3 equals negative 5. Subtracting 3 from each side of each equation gives you q equals 2, and q equals negative 8. This one definitely needs to be checked. Putting in the 2 for q equals 25, and putting in the -8 for q also equals 25. So yes, they both work. Now, you won't be boxed in when you apply the square root rule in algebra.
Solution of quadratic equation by factoring. Steps. Step 1. Transpose all terms on the left side of the equation if necessary. A. Clear the equation of all fractions necessary, then transpose. B. Remove parentheses, then transpose. Step 2. Combine similar terms. Step 3. Factor the left side of the equation. Step 4. Equate each factor to 0. Step 5. Solve the equation in Step 4. Step 6. Check each root by substituting it in the original equation. Solution of quadratic equation by factoring. 1. X squared minus 7x equals 0. X times x minus 7 equals 0 factor. X equals 0 equate each factor to 0. X minus 7 equals 0, x equals 7 at 7 to both sides. Check, if x equals 0, we have, if x equals 7, we have. 0 square minus 7 times 0 equals 0. 0 equals 0. 7 square minus 7 times equals 0. 49 minus 49 equals 0. 2. 25x squared plus 10x plus 1 equals 0. 5x plus 1 square equals 0, factor. 5x plus 1 times 5x plus 1 equals 0, equate each factor to 0. 5x plus 1 equals 0 or 5x plus 1 equals 0. 5x equals -1, 5x equals -1, solve for the roots. X equals -1 over 5, x equals -1 over 5. 3. 18x squared minus 39x equals 15. 18x squared minus 39x minus 15 equals 0, subtract 15 from both sides. 6x squared minus 13x minus 5 equals 0, divide by 3. 3x plus 1 times 2x minus 5 equals 0, factor. 3x plus 1 equals 0 or 2x minus 5 equals 0, equate each factor to 0. 3x equals -1, 2x equals 5, solve for the roots. X equals -1 over 3, x equals 5 over 2.
Here's a quick 3-step process on how to factor any quadratic that's actually factorable. The first thing you have to do when you're given some quadratic equation that you have to factor is that if there's something common to all of the terms, take it out first. It's just going to make your life easier. Then you have to look at what's left. If you're left with x squared plus something x plus something, and it's just a bare x squared, then you can use product sum. And I'll show you how to do that if you don't already know what it is. But you may be left with something in front of the x squared, like 2x squared or -5x squared plus something x plus something. If that's the case, you're going to have to use a little bit more complicated of a method. I'm going to show you how to use decomposition, but you may be familiar with another method. Some people use a box, some people use a bunch of other tricks. You can use whatever you want, but I'm going to show you how to use decomposition because anyone can do it. Okay, so let's follow the process and do this for a few different things. The first one that I want to do it for is x squared minus 2x minus 15. Is there a common factor among all the terms? Now x squared minus 2x minus 15. This one's missing an x, there's no 2 or anything here, so there's nothing we can pull out of all of those. There's nothing common to all of them. Oh, next. Do we have a bare x squared? Yes, we do. It's just x squared minus 2x minus 15. So here's how you do that second step. Find two numbers that multiply to -15 and add to -2. As soon as you find those two numbers, you can plug them right in to this. Now let's figure out what those numbers are. If they have to multiply to -15 and add to -2, well, what multiplies to -15? -1 and 15 multiply to that, but they add to +14, so that's no good. What about negative 15 and 1? Well, those add to negative 14. That's no good. It needs to be negative 2. What about negative 5 and 3? Those multiply to negative 15, and they add to negative 2. Look at that. Those are the 2. They multiply to negative 15 and add to negative 2. Negative 5 and 3. Negative 5 and 3. It's actually that easy as soon as you find those two numbers. Cool. So that one's done. We got rid of our x squared. We've split it up into two separate terms. We've factored it. Okay, let's do this one. Start at the beginning. Is there a common factor among all the terms? 3 and 2 and 5. Nothing common among those. Is it a bare x squared? It's not. So we're going to have to use this thing called decomposition. Here's how you do that. The first thing you do is find two numbers that multiply to this times this. Now this is the only way that this new search is different from the old search. You have to do negative 5 times 3. You want them to multiply to negative 15 and add to negative 2. Now I rigged this so that it would be the same thing. Two numbers that multiply to negative 15 and add to negative 2 are obviously negative 5 and 3. We already found it. But because we have something in front of the x squared, we have to do this in a bit tougher of a way. What we do is we write that first term and that last term just as they are, 3x squared minus 5. And we rewrite the middle term as these two here. Negative 2x as minus 5x plus 3x. Now see, negative 5 plus 3 is negative 2, but we've divided it up. We've decomposed it. Get it? And then, once you get there, factor the first two terms. What's common to both of these? Well, not much, except for they both have an x in it. And when you pull x out of that, you're left with 3x minus 5. Notice that this is each of these terms, but we took away one x from each of them. Then you factor the second two. What's common to these? Nothing. So it's really just a 1 if it's nothing. And because we weren't able to pull anything out, we're left with 3x minus 5. Now we have 3x minus 5 in both of these terms. So we can pull that out, and what are we left with? Well, when we pull 3x minus 5 out of this, we're left with x. And when we pull 3x minus 5 out of that, we're left with plus 1. And that's the factored form of that equation. A little tougher because you have to decompose that middle term, then factor the first two and second two terms. Want to do a couple more here. Is there a common factor among all the terms? Why, yes, there is. There's a common 5. Both of these are divisible by 5. And there's an x in both of them. We can pull out a 5 and an x from both of these terms. When we pull out 5x from this, we're left with just a single x. When we pull 5x out of this, we're left with just 2. We pulled out the x and we pulled out 5 from there. 10 divided by 5 gives us that 2. Oh look, we're already factored because there's no x squared left. That was easy. Finally, let's do this one. Is there a common factor among all the terms? 1/2 x squared minus a half x plus 12. I don't know. Well, let's see. You know what? I could pull out a half here. And when I pull a half out of a half x squared, I'm obviously left with x squared. When I pull out a half from negative a half x, I'm left with negative x. And when I pull out a half from positive 12, I'm left with positive 24. Now, is a 1? Like, do I have a bare x squared? Yes, I do. If we remove that half, which we already factored out, we have x squared minus x plus 24 that we have to factor. So it's just a bare x squared. We can use this product sum. We need two numbers that multiply to 24 and add to negative 1. That's the number in front of x. Well, we got to start reaming off pairs of numbers that multiply to 24. 1 and 24. Those don't add to negative 1 though, so that's no good. Let me cross it out that way. Negative 1 and negative 24. Those don't work. 2 and 12 multiply to 24, but don't add to negative 1. Negative 2 and negative 12. Those don't add to negative 1 either. What about 3 and 8? Don't add to negative 1. Negative 3 and negative 8. Don't add to negative 1. 4 and 6 multiply to 24. Doesn't add to negative 1. What about negative 4 and negative 6? That also doesn't multiply to negative 1. You know what? I've exhausted all the pairs of numbers that multiply to 24. This can't be factored further. And you gotta be on the lookout for that because, you know what, sometimes you just can't factor things. But before you write a bold statement like can't be factored further, you should probably run through all the possibilities like I did. These are all the pairs of numbers that multiply to 24, and not a single pair adds to negative 1. That means you can't factor it further. 3-step process. Follow it, be able to factor anything you want.
Solution of quadratic equation by completing the square. Exploration. A trinomial is a perfect square trinomial if 1. The first and third terms are perfect squares containing positive numerical coefficients or positive numbers. 2. The second term is twice the product of the square roots of the two perfect square terms. To factor a perfect square trinomial. 1. Find the positive square roots of each of the two perfect square terms. 2. Connect the two square roots with the sign of the numerical coefficient of the remaining term, the second term of the given trinomial. 3. Indicate that this binomial is used twice as a factor. Solution of quadratic equation by completing the square. Trinomial. Is it a perfect square trinomial? Factors. X squared plus 8x plus 16, yes. Is it a perfect square trinomial? X plus 4, 2. X squared plus 10x minus 25, no. The sign of the third term 25 is negative. X squared plus 6x plus 36, no. The second term is not twice the product of the square root of 36. Examples. 1. Complete the square x squared plus 14x, then write the factored form. Solution. 1.1. To complete the square, add 14 over 2 square or 49. 1.2. Completed square, x squared plus 14x plus 49. 1.3. Factored form, x plus 7 square. 2. Complete the square x squared minus 5x, then write factored form. 2.1. To complete the square, add 5 over 2 square or 25 over 4. 2.2. Completed square, x squared minus 5x plus 25 over 4. 2.3. Factored form, x 5 over 2 square. Solution of quadratic equation by completing the square. Steps. Step 1. Transpose all terms containing the unknown to the left side of the equation and the constant term to the right side if necessary. Step 2. Divide each term of the equation by the numerical coefficient of the x squared term if necessary. This will change the equation to the form x squared plus bx equals c. Step 3. Divide the coefficient of x by 2, square it, then add the result to both sides of the equation. Step 4. Factor the left side of the equation. This is a perfect square trinomial. Simplify the right side. Step 5. Take the square root of the expression on both sides of the equation. Write the positive negative sign before the square root on the right side. Step 6. Equate the square root on the left side expression to the positive square root on the right side in step 5. Solve for the first root. Then, find the second root of the equation. Step 7. Equate the square root of the left side expression to the negative square root of the right side in Step 5. Solve for the second root. Step 8. Check each root by substituting it to the original equation. Procedure. In an expression of the form x square plus b10 or 10 square minus bx, add the constant term b over 2 square to complete the square. 1. Solve 2x square plus 4x plus 1 equals 0 by completing the square. Solution. 2x square plus 4x equals negative 1, transpose the constant term to the right. X square plus 2x equals negative 1/2, make the coefficient of x square equal to 1 by multiplying all the terms by 1/2. X square plus 2x plus 1 equals 1/2 plus 1, complete the square by adding the square of half the coefficient of x to both sides of the equation. X plus 1 square equals 1/2, factor the left side and perform the operation on the right side. X plus 1 equals positive negative square root of 1/2, apply the square root principle. X plus 1 equals positive negative square root of 2 over 2, simplify the radicals. X equals negative 1 positive negative square root of 2 over 2, solve for x by subtracting 1 from both sides.
Hey everyone, today we're going to be talking about how to complete the square. So sometimes polynomials don't factor so nicely, and in situations like those we're going to have to use this technique called completing the square. I have the steps written up in the corner over here. So step 1 says, look at the x term and take half of its coefficient. Step 2 says square that number, and step 3 says add 0, and you'll see what I mean by that in a minute. Now, before we jump into things, let's talk a little bit about what the goal is for completing the square. What we're going to want to do is take this polynomial and break it down into a perfect square plus a constant. Alright, let's start. So, step 1 says look at the x coefficient and take half of it. So we have 2 as our x coefficient, we're going to take half of 2, so that's going to give us 1. Now, step 2 says square it. So 1 squared is going to give us 1. Now we have to add 0. And what I mean by that is we're going to rewrite our polynomial, but we're going to add this number that we found, in this case 1, and subtract it, effectively adding 0 and not changing the problem. So we have x squared plus 2x plus 1 minus 1 plus 3. Now if we only look at this first part of the polynomial here, notice that this is a perfect square, and these two constants we can combine into one term. So if we factor this polynomial here and combine these constants, we get x plus 1 times x plus 1 plus 2. Now since these terms are the same, we can combine them and rewrite this as x plus 1 squared plus 2. And that's what it means to be a perfect square, to where you can rewrite the factorization of it as the same polynomial squared, because this x plus 1 is still a polynomial. Okay, so now let's look at this example down here. We have x squared plus 6x plus 11. So the first thing we're going to want to do is look at the x coefficient and take half of it. So we have 6x, so that means we're going to need 6 divided by 2, which is going to give us 3. Then step 2 says square it. So 3 squared is going to give us 9. Now we have to add 0. So we're going to rewrite our polynomial adding 9 and subtracting 9, effectively not changing the problem. So we have x squared plus 6x plus 9 minus 9 plus 11. Now, just like before, if we just look at this first part of the polynomial, notice this is also a perfect square. This is going to happen every time when we're completing the square. This is the perfect square, x plus 3. And these two constants we can combine. So, this equals x plus 3 times x plus 3 plus 2. Now we can rewrite this as x plus 3 squared plus 2.
Solution of quadratic equation by quadratic formula. For real number a, b and c, with a not equal to 0, the solution of the quadratic equation ax squared plus bx plus c equals 0 is given by the formula. x equals negative b positive negative square root of b square minus 4ac over 2a. Procedure 1. Write the equation in standard form 0 on one side of the equation. 2. Identify the numerical values of the coefficients a, b, and c. 3. Write the quadratic formula. 4. Substitute the numerical values for a, b, and c in the quadratic formula. 5. Simplify to get the exact solution. 6. Use a calculator, if necessary. 7. Check the solution. Example 1. Solve 9x square minus 12x plus 4 equals 0. X equals negative b positive negative square root of b square minus 4ac over 2a. Equals negative times negative 12 positive negative square root of 12 square minus 4 times 9 times 4 over 2 times 9. Equals 12 positive negative square root of 144 minus 144 over 18. Equals 12 positive negative square root of 0 over 18. Equals 12 over 18 or 2/3. To check, substitute 2/3 in the original equation. 9x square minus 12x plus 4 equals 0. 9 times 2/3 square minus 12 times 2/3 plus 4 equals 0. 9 times 4 over 9 minus 8 plus 4 equals 0. 4 minus 8 plus 4 equals 0. Negative 4 plus 4 equals 0. 0 equals 0.
If you try to solve a quadratic equation, I promise you it's possible without any frustration. If you take everything, move it to one side, sort by x squared, x and the rest. Alright, now take the coefficients, name them a, b and c, and if you know the right formula, you will see that you get the solution in the very next step. Just sing the song in your head. Negative b plus or minus the square root of b squared minus 4a over 2a. Negative b or minus the square root of b minus 4ac over 2a. Okay, let's start with our equation, and our job is gonna be solving this now for x. So let's take minus c, multiply by 4a, and if you now add b squared, it all looks way too complicated. But don't be scared, just take a close look to the left side and you see there's a binomial formula with 2ax and b. So altogether this is the square of 2ax plus b, and now we have only one x. So the next step will be to get rid of the square, and if the right side is not negative, the square root must be one solution. But there's an alternative, cause minus the square root yields the same if you square it. So we write plus minus, and now we are at the point where it only takes 2 more steps to solve it for x. And if you look to the left side, you know what will be next. Subtraction of b and division by 2a is giving us a formula for x. Okay, and it's negative b plus or minus the square root of b squared minus 4ac over 2a. Negative b minus the square root of b squared minus 4 over 2a. Negative b plus or minus square root of b squared minus 4ac over a. Negative b plus or minus the square root of b squared minus 4ac over 2a.
The following problem is an application of quadratic equations, and it states the length of a vegetable garden is 8 feet more than the width w. If the area of the garden is 240 square feet, find the width of the garden. So we have a rectangular garden here, and we're going to label our diagram. So we know something about this. We know that the length L is 8 feet more than the width w, so the length is w plus 8, and it's stated that the width has a measure of w. Now, we also know that the area is 240 square feet. Recall that the formula for area is length times width. So we're going to use this information to set up an equation that we can solve. So now, knowing that the area is 240 feet squared, we're going to say that the length w plus 8 times the width should give us 240, which is our area. So now we will distribute, and we obtain w squared plus 8w equals 240. Now, recall that this is a quadratic equation. So what we need to do, our goal will be to get this equation equal to 0 so that we can apply our box method of factoring to solve this equation. So what we'll do is subtract 240 from both sides. So now our new equation states that w squared plus 8w minus 240 equals 0. So what we're going to go ahead and do is apply our box method now. So we'll go ahead and paste in our box that we're going to use to factor this polynomial, this quadratic equation. And recall that we should always write the first term in the first box and the last term in the last box. So I'll write w squared here and minus 240 here. Now the remaining two boxes is what we need to figure out. So we will write negative 240 here. So we need the factors of 240 such that when added we get a difference here of 8. Now we know we're going to have to subtract because we have two opposing signs, a positive and a negative here. So the only factors that come to mind are 12 and 20, since 12 times 20 is 240. So let's think about this for a minute. A positive times a negative or a negative times a positive are the only ways that we will get a negative 240 here. So this helps us in determining the signs for 12 and 20. So negative 12 and positive 20, because that will give us a difference of positive 8. So let's fill that in. Negative 12 w plus 20 w. So now that I've got that, all I need to do is factor out the greatest common factor along each of the rows and each of the columns, and I should obtain some values for w. So let's see here. The greatest common factor for the first row is w. The greatest common factor for the second row is 20, and we will write plus 20 since the contents of this box that it's touching are positive. Now let's look at the first column. The greatest common factor here is w, and the second column, the greatest common factor there is negative 12. So we write negative also because the contents of this box are negative. So now we have our two factors. So our equation, our new equation, looks like this. W plus 20 times w minus 12 equals 0. So using the zero factor property, we will set w plus 20 equal to 0 and w minus 12 equal to 0. In the first case, we obtain w equals negative 20, and in the second case, we obtain w equals 12. Well, let's think about this for a minute. We have two widths. However, can we have negative distance? We can't. So, because of that, negative 20 cannot be a solution to our problem. The width of the rectangular garden is 12 feet, and we have solved our equation using the box method of factoring.
To summarize our topic for today, a quadratic equation in one variable is an equation of degree 2. Its standard form is ax squared plus bx plus c is equal to 0, where a, b, and c are real numbers and a is equal to 0. Quadratic equation can be solved by extracting square roots, by factoring, by completing the square, and by the quadratic formula. I hope you guys learned from our topic for today, and I'll see you again on our next class.
Activity. Practice your skills. I solve by factoring. 1. X squared minus x minus 2 equals 0. 2. X squared plus 16 minus 36 equals 0. 3. 8x squared minus 6x minus 5 equals 0. 4. 2 times 3x squared plus 4 equals 19x. 5. X squared minus 4x equals 3x minus 12. B. Solve for x. 6. X squared minus 8x equals 0. 7. X squared equals 14x. 8. 4x squared equals 32. 9. X squared minus 144 equals 0. 10. 81 minus x squared equals 2x squared. C. Solve by completing the square. Check the result. 11. X squared plus 6x equals 16. 12. X squared minus 12x equals negative 18. 13. 6m squared minus 20 equals 9m. 14. X squared plus 7x equals 14. 15. X squared plus 2x minus 5 equals 0. D. Solve each by using the quadratic formula. 16. X squared plus 9 equals 0. 17. X squared minus 7x minus 8 equals 0. 18. 3x squared minus 2x equals 5. 19. 7x squared plus x equals 2. 20. 2x times x squared plus 3 plus 1 equals 0.